Hey, morning, everyone.
Morning, John.
Good morning.
How have you been, Mike?
Good. We had a good meeting without you 2 weeks ago.
I'm sorry, come again?
We had a good meeting without you 2 weeks ago.
Did y'all?
Yeah, we spent almost 45 minutes talking about coolant requirements.
Oh, okay. Wait, so
There's a recording of it.
oh, okay. Yeah, I guess I'll have to go back and take a look. Yeah.
We had a discussion about what happens between regular tube style cold plate versus microchanneled cold plate or rear door heat exchanger, and what the requirements are for filtering the coolant, and what kind of process would you have to go through if you had an existing system that was tube style heat exchangers and you upgraded one of the servers to a microchannel heat exchanger. How would you get there? Because you'd have to filter your coolant or clean your coolant, or so we need some like best practices or something like that to for what happens when you start using microchannel stuff instead of regular tubing.
Yeah, yeah. Yeah, and I think we're gonna have some amount of high level information in the white paper that talks about aluminum microchannels. Well, aluminum microchannel heat exchangers in indoor applications. So yeah.
But in that case, you're probably in the 30 micron range or something like that for the particulate size that you'd have to get rid of in the coolant.
Yeah. I think it depends on the size of the channel, to be honest, that's needed in the heat exchanger. And I think we can double check that with Sankar, basically how he set that up for the analysis that was presented at the Global Summit. And I think in general, ASHRAE's guidance is sort of capturing particulates. And then there's a factor, it's either 2x or 10x, but in general, the community, what I've seen is the general sentiment is you try to do 4 times that, right? So if you have a 100 micron channel, then you
do 25.
You try to filter down to 25 microns. So but I think with the heat exchanger, it just depends on whether it's just a heat exchanger that's attached to the rack and the rack is still air cooled. Then maybe, you may not need to filter aggressively.
But you
if
certainly
it's
can't use
door
facility water.
and then it goes into cold plates, then yeah, then it would be, you'd probably have to be pretty careful with the particulates.
Yeah, a lot of the discussion was about how do you upgrade? So if you've got several tube style cold plates in servers and you swap one of the servers out for something new that's higher power density and uses microchannel cold plates, then if you just plugged it in, you'd probably clog your cold plates. So you'd have to change your, we kind of need to define some best practices for how you would get there. So you'd have to change your filters and then let the system run for some period of time to clean out whatever larger particulate material was in the coolant, and then potentially change the filters again. And once you get the coolant clean enough, then you could put a microchannel based server in.
Okay, so the concern over here is with the fact that the heat exchanger would introduce particulates into the system, large particulates.
No, well, I mean, if you had tubing for the rear door heat exchanger and tubing for the cold plates, then your filtering requirements are almost non-existent. Because you've got 1/8 inch or 1/4 inch or something like that diameter tubing, you could let small rocks go through and it would work just fine. But if you introduce microchannel either on the rear door heat exchanger or on the cold plates, then you've got some pretty severe filtering requirements for the coolant. So if you ever upgraded an existing system, it might have all kinds of particulate material that came from, shedding from the inside of the coils or pipes or pump or anything like that. And if you're not doing aggressive filtering on it and you let that crap go through the microchannel cold plate, you'd clog it up. So if you're building something new, then you would have clean everything and you'd be relatively straightforward. But if you were ever to upgrade a system from tubing style to microchannel, then how do you get there? Just changing the coolant might not do it because you might have still crap inside of the pipes or pumps or something. So some of the people were interested in guidance on, how you could upgrade a system from less severe to more severe filtering requirements.
Interesting.
And then even at 25 microns, how careful do you have to be if you like replace the pump or anything like that inside there? How much crap is going to be inside of a new piece of tubing or something that you put in there? So do you have to flush this stuff out before you introduce it into a critically filtered coolant system? It doesn't seem to be any guidance on how to do this.
Yeah, I think the only guidance that's truly out there is, the guidance to build and ship clean. And I think that, yeah, I agree. There's no specific guidance out there.
Yep. So the coolant group that's in the cold plate group is starting back up again. So this, may end up being a bunch of requirements that we could come up with. Well, actually, they would come up with for cold plate. We could come up with for rear door heater exchangers for how clean the coolant needs to be, and we can just pass that off to the coolant group.
Yeah, I mean, I'm curious to know what others think here, but my gut feeling is that whatever they come up with for cold plates will probably work for door heat exchangers. But yeah,
but I think that input ought to go over to that group. That if typically the microchannels in a rear door heat exchanger are significantly larger than they are for a cold plate, then our input to the coolant group would be whatever is good for cold plates is good for rear door heat exchangers.
Yeah, and I think what we can do is we can probably talk about channel dimensions. Like for example, in a regular tube fin type heat exchanger in a door, this is the usual internal diameter that you would see in this range, and then I can check with Sankar about the aluminum microchannel heat exchanger, and what sort of channel dimensions do you see in that case? And I think that's the sort of information we can pass along, because if you compare it to channel sizes you see in cold plates, it can be in, could be 150 microns, right? Yep. And then you also need to check the channel sizes in the quick connects. If they are small quick connects, they usually have pretty small channels. So there's that as well. So yeah, but I agree. We can sort of put this information together and sort of pass this along. Jabari, you
yeah, I was just going to tell Michael that the cold plate group did release 1 or 2 specs about the transfer fluid, whether it's properly treated water, and they had some micron size recommendations in there for filtration. So I dropped the link to one in the chat. So if maybe what you're looking for is in there, and it's like 5 micron, by the way. So I didn't read it to see if that was commissioning or what, but I mean, in practice, I probably would use a consistent micron size no matter what I was doing if the pressure drop wasn't too bad. So just FYI.
Okay. Thanks, Jabari. Thanks, Mike. I think we can get started with truly get started with the call. So, hey everyone, it's been a while. I think the last time we met was probably prior to the global summit. And I think it was good to see quite a few people over there. I also noticed that there are a lot of new folks who have joined the call. So we don't have quite a lot on the agenda. So I'm wondering I'm thinking it might be good for us to kind of go around and maybe do some quick introductions. I'm gonna start in the order I see it on my interface. So Rajesh, do you mind just quickly introducing yourself?
Hey everyone, this is Rajesh Kasakurthi. I am an FAE engineer with Delta. I work on all liquid cooling products, and I am interested in working with the group or understanding and supporting in any way I can.
All right, welcome, Rajesh. Thanks for joining the call.
Thank you, John.
Next is Howard Andrews from Lotz. We can't hear you, Howard. We can see you, but we can't hear you.
There we go.
Oh, there we go.
My name is Howard Andrews. I work for Loads, and I've only been involved in this for a month or so. I worked at TE for many years, and I'm mostly interested in the interconnect business, but at the same time, I'm catching up on many things as it relates to OCP, and so I'm going to many of the discussions to see, just to become familiar with all that's happening. And this is one of those that doesn't directly relate to interconnects, but it's an interesting piece, and whether I stay with this group or not remains to be seen.
Well, welcome, and thanks for the introduction. And I think there might be some discussion related to interconnects, but it might be more related to power and communications when it comes to doors. And I think maybe Juan Carlos can comment on that about one of the future efforts once we get to that area. So welcome. And then we have Anne Catherine.
Yes, hello from my side. My name is Anne Catherine. I'm from company Rittal. I'm supporting Juan Carlos on the cooling side in Rittal. I am normally responsible for the solution sales for IT cooling products. And Juan asked me to join this group, and now I'm first listening and learning from you, and I'm keen to know what you're up to and what you're planning in this group. So yeah, I'm happy to be here, and yeah, thanks for letting me in and inviting me.
All right, welcome. Yeah, thanks for joining the call. I think otherwise we have some pretty familiar faces. So let me get started with going over the agenda. I'm gonna go full screen. Can everyone see this?
Yep.
Yes.
Yes.
All right, excellent. So so the 2023 Global Summit has wrapped. It was great to meet quite a few people over there. And I just want to thank everyone who attended, who who were there in the cooling environments track, and especially to the presenters for just the incredible amount of work they put in to be ready for the presentations and to support the sub-project. Miraculously, we actually ended each discussion on time. So, kudos once again, and thanks to everyone who supported the Global Summit, and long may it continue. Just a quick reminder: if you weren't able to attend, but are curious to know what was presented, the OCP has already posted a lot of the videos and the slides from the presentations at the summit, including the keynotes that took place on the first day, and then a lot of the engineering discussions that took place on the second and the third day. As you can see, we have all the door heat exchanger related presentations over here, but you can find all the different presentations over here categorized by the different projects. So we are obviously a part of cooling environments. So if you want to make yourself familiar with what's been going on, and are just curious to know more in a specific area, they have access to both the video on YouTube as well as I think the PDFs of the slide deck. So feel free to help yourself to that. Having said that, OCP is always open to feedback. And since we have not been able to meet since the Global Summit, I just want to make sure I think our group has an opportunity to provide feedback. So I just want to ask the community over here, does anyone have any specific feedback that they'd like to share with OCP on the Global Summit?
Hi, John. The same like the last year. I think this is it was really cold in the room, which
Okay.
we presented everything.
So basically, HVAC was in overdrive. All right, I'll pass this along.
Yeah.
Well, you were presenting on cooling, so that's appropriate.
But this is too much, I think.
Yeah, well, and I think our intention is to be efficient, right? Is to be just the right amount of cool. So
Yeah, increase the
we may
supply
have gone
temperature
overboard over here.
will help. Yes.
Yeah. Well, thank you. Anyone else have anything they'd like for me to pass along?
Hey John, this is Ben Sai. There were certain meetings or presentations that I couldn't even get in the room. There's so many people. There are some of the smaller settings, right? I can't think of anything specifically, but where there's so many people they had to close the door effectively, and if you weren't in, you weren't in.
Yeah. And then we're not able to access. Ben, if I can maybe put you on the spot, do you remember like which specific track this was? Because I think that'll be the obvious question they'll have for me when I pass this along.
Yeah, so I remember some specifics on some of the cooling. I think if I recall correctly, specifically like the immersion cooling ones. Some of those were really hard to get into.
Okay. Yeah, and I also recall on Wednesday morning, I think in the track where they were talking about optics, when Andy Bechtelsheim was talking, and I think after that, with a couple of others, it was basically I had to stand at the door and look in, kind of, sort of twist my head around to kind of get a glimpse of the slide deck and what was being talked about. So yeah, no, that's true.
Mm-hmm.
Okay. Anyone else?
One point more. There are some meetings tables for meetings and so on along the summit, and was really noise. We couldn't hear each other, and what was really difficult to have a meeting there. And maybe outside it was also place to talk, but it was the same problem. The noise was very high because we have music in the near and so on. So maybe to figure out how to make place to be able to have a meeting without too much noise.
Okay, so basically have spots for,
yeah,
I guess quieter spots for, if I can spell quieter, quieter spots for meetings. Juan Carlos, did you try going to the I don't know what you would call it, like the first floor, where they had the poster session, not the one on the second floor, but on the first floor. And then
you're right.
There were some spots over there before you took the elevator or the stairs down to the poster session. I think in general it seemed a lot quieter over there, but anyway, I'll sort of pass this along. So would you say that all the spots, I guess all the seated areas were not conducive to meetings, like they were all pretty noisy?
Yeah. I remember once was the music. It was not very loud, but was enough to be difficult to understand. The other people are in the other side of the table, so therefore.
Okay. All right. 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 If there's nothing else, I'll move along. Thank you for the feedback. It's been a while, so I just wanted to give a quick summary of the efforts. So these two topics over here were presented at the Global Summit. The aluminum microchannels door heat exchanger applications. I'm currently working with Sankar to have the white paper draft ready. We're hoping by early December, so then we can probably review it with this community, and that way we can make sure everybody's on board with what's being shared in that white paper. Similarly, I'm working with Carl and David on a weekly basis to kind of start putting the white paper together, and we're also hoping to have this ready sometime in December, so that we can have all the industry experts who are on the call take a look and just make sure that whatever's in there makes sense and maybe isn't contrary to popular understanding. So yeah, so with these efforts, the intention is to have these two white papers contributed, and then the intention would be to kind of do that by mid-January at the latest. But these are going to be two white paper contributions that will be coming out pretty soon. And I also see Jarrett on the call, and I don't intend to put you on the spot, Jarrett, but I think also with the frame-based door heat exchanger, there might be potential for contributing something over here also, right? Of course, dependent on discussions internal to Meta, right?
Yep. We still have some discussions to have about, when exactly what we will contribute. So still need some time for something final, but absolutely.
Yeah. And how was the experience showing off the prototype in the experience center?
It was nice. Definitely was cool to get a lot of different perspectives from some of the folks there. Definitely a lot of interest just in the application. I think it's something that, people haven't necessarily seen before. So definitely think it went well. It was also nice to meet some people from, some people are on the call here, but I guess actually aren't on the call today. I saw Jabari and others there, so that was a good time.
Right, excellent. Yeah, so we can definitely follow up on that topic, as discussions internal to Meta progress. But thanks for doing that. On the and then transitioning to efforts that are planned. I think Jabari talked about the revision 2 of the door heat exchanger requirements. And I think during the presentation, Jabari, you talked about potentially having this in by Q1 of next year. Is that correct?
Yeah, I think that was already presented. So yeah, I think that's feasible.
And is there would there be any specific support that you would need from the community in terms of I'm assuming the intention is to make some specific updates, right? And then sort of related to that, what are some of the areas that need to be touched on, so you can get the relevant information and put it in the document?
I think the biggest one was probably the model, the 3D model of the CAD, to make sure that if you have a CDU for the new OpenRack V3 and the new blind lead manifold, if you have a CDU with a door heat, an internal CDU with a door heat exchanger, if everything can fit, like if the hoses can fit, if the door can close properly, that kind of stuff. Because you were seeing, like, when you look at the current documents, that maybe there might be a space issue. So I think that was the biggest thing, just being able to get that model done and updated in the requirements document.
Okay.
The other more around like codes and like current revisions of codes and standards, and references to updated OCP documentation. So like for ASHRAE, like they're still using W1 and stuff, and it's been updated. So that stuff I can do, but like the electrical standards I may not be as familiar with. So like the EJ45, etc. I'm not that familiar with those things. So we probably need someone to run through from the electrical perspective.
Okay, yeah, and I think on that one we can probably get support from one of the many suppliers that are on the call, so you can definitely get that checked, because they need to make sure that's in check prior to shipping products, so we can definitely leverage that.
Okay.
Yeah, no problem. Also, Jabari, we can talk about this issue.
Okay.
Okay, excellent. And then moving on to what we consider as future efforts. So these would require, these haven't been kicked off yet, as they require further scoping and clear definitions as part of work streams, which is how the cooling environments track prefers to introduce new areas or new efforts. So starting from this point onwards, we want to be compliant with that as one of the sub-projects within cooling environments. And then these were topics that were discussed while at the global summit. I think one of them is reference documentation for door heat exchanger deployments. Unfortunately, Benny cannot be on the call today, but because he's on his way to supercompute. But this is one area that we've had support from Vertiv on. I think And I've put a link to one of the Vertiv reference documents over here. But it's not specific to door heat exchangers. It's specific to like an integrated rack solution, which is a sort of a multi-rack concept and includes a bunch of solutions that form the basis of the integrated solution. So one thing I would suggest is for the community members to take a look at this reference document. And then maybe help us understand, okay, first of all, is this a usable reference point? And then the second thing is, do we believe we can form something similar, but specific to the door heat exchanger area? So yeah, I don't know if anyone's had a chance to look at this, but this is what's been shared, and I think as a first step, it'll be helpful for the community just to look at this and then maybe provide some. I would appreciate some feedback on, hey, the certain aspects of this, of this reference document can be used specific to door heat exchanger applications, or otherwise it's like, no, maybe it needs to be something else. But this is what's been shared so far. So please take a look and then maybe send an email in response to the whole community group with some thoughts on how to follow up on this. Okay. The second area is defining interfaces for door heat exchanger used with OpenRack v3. This was brought up by Juan Carlos, and there is a preliminary document that's been put together. It seems like I don't have access to this, well, on the OCP project format. But Juan Carlos, can you maybe just provide a quick overview for those on the call, just sort of talking about what this is all about?
Yeah, no problem. Yeah, the idea behind that is to define, or maybe not define, but more give an idea how to bring the water from inside the rack outside, and to connect the rear door with facility water, the rear door with the DLC secondary loop, in case we are using rear doors like air assisted units, or in case we are using hybrid heat exchanger, how to connect everything together. But the OpenRack v3 is a little bit different than the 19-inch. So we have not the same interfaces to bring the piping through the bottom or from the top of the rack. Sometimes there are no place for that, and we have to figure out how to bring the hoses outside the rack when the rear door is placed there. And I think will be good idea to talk about between the suppliers and the customers as well, to figure out how to connect electricity from the DC bus bar to bring out the hoses and this stuff, to the communication between the rear door and the rack, and yeah, everything in that way.
All right, awesome, thank you. Yeah, so as I said previously, each work stream will have a work stream scoping document, and then who all needs to be involved. So I think that way the efforts can be structured appropriately. And then the intention would be to ensure that the onus doesn't fall only on Juan Carlos to figure this out. So It's to basically make it to truly make it a community effort. Yeah. And then the last area that's still TBD is following up on the white paper, talking about aluminum microchannels that are predominantly used in the HVAC and automotive industry, and how do you make that a solution for door heat exchanger applications in data centers, or at least in ITE applications. So this would be a follow-up that would then dive a lot deeper on, okay, we have highlighted considerations, but now the next step is how do you make this happen? So this could potentially cover, manufacturability. How would the heat exchanger be integrated into the door solution? What are considerations for coolants that are predominantly used in liquid cooling applications? And then how do you make sure you have all the necessary checks in place so that this can be a viable solution at scale? So this is still TBD. It needs to be scoped out. We need to find the appropriate partner to drive this. But I think the general feeling is that this also will be a pretty valuable contribution coming out of this community. So, all right, and then moving along to just a couple of topics to cover. One is we had a request from the hardware management workstream, which Mike is a part of. And apparently in that conversation, the question came up that, CDUs, a CDU is not an all-encompassing term. There are other components that are being introduced. One of them is the reservoir and pumping unit. This is obviously used in air-assisted liquid cooling. I think another one is the term HRU. So the question was, in the OCP glossary, the CDU is defined as a piece of equipment used in liquid cooling systems that is responsible for pumping and conditioning the coolant before it is distributed to the components being cooled. So the question that the hardware management workstream has is, are RPUs and HRUs subcategories of CDUs, or should they be considered something completely different? And I think this is where there's a there are folks who believe one way, and then there are folks that believe another way. So we've had a bunch of online discussions, and we've sort of come back with, I think it'll be simpler to kind of separate them out. So there's a definition for the RPU that says it's a component in liquid cooling systems that houses the coolant and pumps to circulate it. And then similar to the CDU, but does not include conditioning functions like heat exchange, which, based on the specification that's been contributed for the RPU, this definitely aligns with that. However, I think on the cooling environments leadership side, we are not as familiar with the HRU term. So I was just wondering if there's anyone on the call who's more familiar with the HRU product and whether or not this definition over here aligns with that. It basically says it's a device in liquid cooling systems for expelling heat from the coolant into the environment, typically using heat exchangers. So anyway, I just wanted to ask the community if anyone's familiar with the term HRU.
Yeah, from my side, I think that come from Sutakor, I think. But I'm not sure. But the first time I heard this HRU was with Sutakor. Okay. But at the end, this is the same like the air-assisted units. The air-assisted unit could be the rear door air-assisted unit, the sidecar air-assisted unit or in-rack air-assisted unit. So this is only a part of this familia air-assisted units, I think. And maybe it's better if we say, okay, in-rack air-assisted unit.
Yeah, I think if we are defining an RPU, which is a part of the air assisted system, I can also ask to add request to add a definition for AALC, right? So, and then I think with the HRU, so what do you think about this definition over here? Do you think it's representative, or do you believe probably better off reaching out to Zutacore and asking them about this?
No, I think it is okay. I think this is okay. But to ask Zutacore, maybe it's also a good idea.
Okay, so yeah, so we can say, hey, probably need to check with them.
Because I am not sure if they tell HRU WOTA for the CDU. Also, I am not sure in that way.
Okay. Okay, yeah. So okay, I'll pass this along. Basically, what I'll say is there are no concerns with the definitions that are already in the that have been proposed. But I think otherwise, maybe it makes sense to add a definition for AALC to sort of complement RPU. But I think with HRU, the definition is fine. But it may come from Zutacore, so it might make sense to check with them. So I'll pass this along to Jordan because I know the Zutacore folks are quite active in the cold plate work stream. So I'll pass this along to Jordan. Anyone else?
So is the intention that the HRU is liquid to air, or also encompasses liquid to liquid?
I think when you start defining, the mode of heat transfer, I think it becomes more contentious. I would say coolant to air for sure.
But is it also the heat exchanger that would be in a CDU?
Yeah, we have to check it with Zutacore. I think this is the best way because I am not pretty sure if HRU for them is the HRU water and HRU air. Yeah, the same we could say the CDU air and CDU water. At least you reject the heat into the air or into the water.
But if the HRU is only liquid to air, then we probably need yet another definition for liquid to liquid.
Yeah.
But I think
liquid to liquid is CDU.
But that would be covered by CDUs, right?
But
Yeah.
the CDU is the whole assembly that has filters and pumps and a heat exchanger and stuff in it. So a CDU would have an RPU plus a liquid to liquid heat exchanger in it.
No, I think RPU is to reject the heat directly into the air. So you have a pump, a liquid to air heat exchanger in one box, and you can deploy this HRU.
Right.
HRU.
Right. But an RPU could also be a subcomponent of a CDU.
No, I think they are two very different products.
Why?
One is a subcomponent of the other.
If an HRU it will also encompasses liquid to liquid, then an RPU plus an HRU could be a CDU.
So I explained something we are doing in retail. We say CDU air if the heat is rejected into the air. So there is a pump with a liquid to air heat exchanger. If this is a CDU like we are speaking here, we say CDU water. And so in that case, the pump, there is in the box, there is a pump and a plate heat exchanger, and you reject the heat into the primary loop. Yeah. I think, therefore, it is better if we talk with Zutacore and we check what is the idea behind HRU.
But if the HRU is only liquid to air, then we probably need a definition for liquid to liquid.
Yeah,
Or yet another.
CDU. Also, the idea of liquid to liquid is the CDU.
Yeah, because the CDU is not liquid to air, right? CDU,
Yeah.
the assumption is always liquid to liquid, is basically connecting the primary and the secondary loops. Anyway, I feel like
yeah.
I feel like we're having the same argument on this call as we are on the other happened on the other one. But I think I'll pass this feedback along, and then let's see where it goes. Okay. And then one last thing is, and this is just communication from OCP. I think everyone should have received this email from Michael Schill. Everyone on the Door Heat Exchanger email thread. So if you are attending Supercompute next week, the Cooling Environments Project community and leadership have an evening meetup that's planned for Wednesday. From 6 to 9 p.m. It's I believe it's sponsored and already paid for. But the request is to RSVP if you are going to be at Supercompute and going to be available Wednesday evening, and would like to meet folks who are involved in the Cooling Environments Project community. So if you're going to be there, or you know someone who's going to be there and would be interested in meeting other folks involved in OCP, please forward this information to them, and then ask them to sign up at the link. All right, and then one last thing is the next bi-weekly call is on Thanksgiving, so I will be canceling that, and then our next call will be in December. So before we sign off, is there anything else anyone would like to bring up real quick while we have time?
Not from my side.
All right. Thank you, everyone. And if I don't talk to you, have a great Thanksgiving break, and see you in December. Thanks all.
Yeah. Thank you. Bye-bye.
Yeah.
Bye-bye. Thanks.